The parametric form of a straight line can be used to derive many formulas. Now we will derive the formula to find the shortest distance from a point to a straight line. The shortest distance from a point to a straight line is the perpendicular distance from that point to the straight line. To derive the formula for this distance, look at this straight line ax plus by plus c equals 0. We also have a point p0, x0, y0 outside this straight line. We now need to find the perpendicular distance from p0 to ax plus by plus c equals 0. There are many ways to find this perpendicular distance. Some are long and some are short. We are now going to find it using one of the shorter methods, which is by using the parametric form of a straight line. So the gradient of this straight line can be given as minus a over b. Therefore, the gradient of any line perpendicular to it will be b over a. We'll take the point of intersection of these two lines as Q. Let the point Pxy be any random point on this perpendicular line. Now we need to find the equation of this perpendicular line in terms of the parametric form we learnt in our previous video. Since the fixed point is P0, X0, Y0 and the gradient is B over A, we can write the parametric form as X equals X0 plus AT and Y equals Y0 plus bt, where t is a parameter. Since the point Q lies on this perpendicular line, we can write the coordinates of Q as x0 plus at1 and y0 plus bt1, where t1 is the parametric value at Q. Using the coordinates of P and Q, we can find the distance between them using the distance formula we learnt before. That would be square root of x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared. So this will give us x0 plus at1 minus x0 whole thing squared plus y0 plus bt1 minus y0 whole thing squared. So the x0s and y0s cancel each other. This will finally give us d equals t1 into square root of a squared plus b squared. Now we need to find the value of the parameter t1. We can see that the point Q also lies on the line ax plus by plus c equals 0. So the coordinates of Q must satisfy this equation. So when we substitute the values of Q, we get a into x0 plus at1 plus b into y0 plus bt1 plus c equals 0. So when we simplify this, we finally get the value of t1 equals minus ax0 plus by0 plus c over a squared plus b squared. Now we substitute this into the first equation. So this will give us d equals minus ax0 plus by0 plus c over a squared plus b squared multiplied by the square root of a squared plus b squared. So this will cancel and give this a square root of a squared plus b squared. Distance can never be a negative number. So to avoid this, we add in the modulus in the numerator to give us this final formula. Modulus of ax0 plus by0 plus c over square root of a squared plus b squared. For example, you have a straight line 3x plus 4y plus 2 equals 0 and you are required to find the shortest distance from the point 7, 1 to this line. Using the formula, we can substitute the values. Here a equals 3, b equals 4 and c equals 2. Also x0 equals 7 and y0 equals 1. So this will give us the modulus of 3 into 7 plus 4 into 1 plus 2 over 3 squared plus 4 squared whole thing square root. So finally we get the answer as 27 over 5 units. Now for the tip of the day. Sometimes you may get the normal distance as 0. This does not mean that the equation or method is wrong. It only means that the point we considered is now on the given straight line. That's why the distance is 0. We have exercises in the description below for you to practice this new formula. The answers are also given for your reference. Subscribe to our channel and click the bell to keep yourself updated on our upcoming videos. Until we meet again, take care.